Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay, the moment of inertia of a compact disk is about 10 to power 5 kilogram meter square. Part A, find the angular momentum L, whose formula is also given in the statement that L equal to I omega when the disk rotates at omega over 2 pi equal to 735 revolution per minute. And part B, find the approximate value of the quantum number small l. Okay, now we move to its solution, but before starting our solution in a proper manner, we introduce or include some snapshots which will help us, which will provide a foundation for our solution. Okay, dear students, first snapshot is a table of physical constants. There are a lot of physical constants have been given, and this table has been taken several times in our previous problems, previous videos. So we do not give enough time, and we move forward. Okay, next, joule is defined as or its alternate units are given as kilogram meter square per second square. Okay, it will also be used in this problem. Next, in next snapshot deals with the angle conversions. Okay, 1 radian is equal to 57.30 degree, and this alternatively becomes equal to 180 degree divided by pi. Okay, 1 degree is equal to 0.01745 radian. This alternatively becomes equal to pi over 180 radian. 1 revolution is equal to 360 degree, and this is alternatively equal to 2 pi radian. 1 revolution per minute, that is within bracket it is written rpm, that is revolution per minute, is equal to 1.047 radian per second. Okay, in the next snapshot several formulas have been shown. First is about orbital angular momentum. Capital L vector mod or modulus value or absolute value equal to small l into small l plus 1 under root into h cut, where h cut is outside the under root, and h cut is equal to Planck's constant divided by 2 pi. Okay, it is also called h cut or h reduced or h bar. Okay, next is orbital magnetic quantum number Lz equal to ml h cut or h bar or h reduced, where h cut or h bar or h reduced is Planck's constant divided by 2 pi. Okay, here small l is written as a subscript of m, and m values of ml vary from 0 to plus minus 1, plus minus 2, and so on up to plus minus l. Next is a special quantization cos theta equal to Lz over L mod or L absolute value equal to ml over L into L plus 1 under root. Okay, dear students, now we are starting our solution in a formal manner. Okay, part A, L is equal to I omega. This is given in the statement. Okay, given I equal to 10 raised to the power minus 5 kilogram meter square. This is also given. Okay, I is also given. However, about omega, the given condition is that omega divided by 2 pi is equal to 735 revolution per minute. Okay, from here omega becomes equal to this. Okay, what is that is to say 2 pi has been shifted on other side of equality, and from denominator it has been shifted to a numerator. Okay, next we have chosen a conversion factor. Okay, what conversion factor? 732 pi. Yes, we have chosen revolution per minute is equal to this so many radian divided by second. Okay, if any confusion, we can go back to that snapshot. Okay, that's this. uh, One revolution per minute is equal to 0.1047 radian per second. Okay, one rpm is equal to 0.1047 radian per second. Okay, so we have used this conversion factor. Okay. By using this conversion factor, our omega becomes equal to 76.95 multiplied by 360 degree over second. Okay, next, actually dear students, next we have used another second, that is to say 2 pi radian is equal to 360 degree. Okay, 2 pi radian equal to 360. 2 pi radian, yes, 2 pi radian is equal to 360 degree equal to 1 revolution. Okay, so now in place of 2 pi by 2 pi radian, we will not use this, we will use 1, only 1, that is 1. In place of 2 pi by radian, we will use 1. In place of 2 pi by radian, 2 pi by radian, 2 pi by 2 pi radian, we have used 360 degree, and in place of 360 we have used 1. Okay, because it is equal to 360 degree, 360 degree, 360 degree, 360 degree. First we have used in place of 2 pi radian 360 degree, and then we have replaced it by 1, simply 1, not full revolution, because revolution has already been taken as a conversion factor. Okay, so our omega has become equal to this, omega equal to 76.95 second inverse, that is per second. Okay, hence equation number 1 becomes, we will put these two values, first value is given in the statement, and second value we have determined this. Okay, so now we will put these two values in equation number 1. This implies that equation number 1 becomes L equal to I omega. I is this and omega is this. Okay, this becomes equal to this into this kilogram meter square per second square. Okay, value of L is final. Okay, 7.695, or we can also write it as 7.7. Okay, 7.695 into 10 raised to the power minus 4 kilogram meter square per second. Okay, now we come towards part B. Okay, part B using this formula. Okay, this was shown in the snapshot. Capital L is equal to under root small l into L plus 1 into H cut or H bar or H reduced, where H cut or H bar or H reduced is Planck's constant divided by 2 pi. Okay, so this implies that in place of L we have put its value which we calculated in the previous step. Okay, this in place of L, this value, this is equal to this value into H. This is the value of H, and this is the value of 2 into pi. Pi, that is to say 22 by 7, is usually taken as 3.14. Okay, pi 22 by 7, it is a non-terminating, non-repeating its decimal representation is non-terminating, non-repeating, it goes endlessly. That is to say, after decimal, digits change continuously and they do not stop anywhere, so it is a very special number. Okay, pi. Sometimes also included in transcendental numbers. Anyhow, this is a separate discussion. Now dear students, this is value of Planck's constant h. This value we have taken from the first snapshot in which a table of physical constant was shown. Okay, this is the value of h Planck's constant, and this is the value of pi 22 by 7, that is 3.14. Okay, this implies that this becomes equal to this. Okay, next is just simplification, nothing else, just simplification. So L into L plus 1 under root becomes equal to this. Actually 10 raised to the power 34 is plus 1, while 10 raised to the power minus 4 is minus, so it will become 10 raised to the power 30. Okay, this implies that within a bracket it will become L square plus L square plus L under root is equal to this. This implies that if we take square on both sides, then we will get L square plus L is equal to this square. Now because L square is very greater than L, so L will be approximately equal to this value, because what we will do, we will assume this value L square plus L equal to L square. Okay, only L square, and then we will again take under root on both sides, and hence L will become approximately equal to this value. Okay, because L square is very greater than L, so we are neglecting single L, and L square has become equal to this square. So taking under root on both sides, L will become equal to this value. Okay, so this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.